Good morning, everyone. Today we are going to learn about the most important chapter in class 12 chemistry, and it's just number 2. The chapter 2. It's a solution. Okay, we need to learn it. It's really very important in our daily life. We have to learn this chapter. Okay, so we have some knowledge about pure substances and mixtures. We learn these things in first year. Okay, so we know that how can we get the mixture. We get mixture by adding pure substances. Okay, so let me give you an example of mixture. Okay, we know that there are some alloys. Okay, first of all it's brass, and second one is German silver. We know that the properties of brass is completely different than the German silver. Okay, so in brass there's pure substances are copper plus zinc, and in German silver there is also copper, zinc, and another one is nickel. See, this here is just the one component is changed, and we get the product which completely different from that product. Okay, so this thing that solutions are really very important in daily life. We need to and let me we need to learn these things. Okay, and let me give you the second example where if we make 1 ppm fluoride ion 1 ppm fluoride ion solution, then it's good for to decay. That means it decrease the to decay. Okay, and if we increase the concentration of it by 0.5, then it's not good for tooth, then it's molted the tooth. Okay, and these all are in your book. Okay, sorry for this. First of all, you have to read the whole book. Okay, you should go through thoroughly the whole line. The every line you should read that, and then see if you want to clarify your board exam and obviously that national level entrance exam, then also you have to read your textbook thoroughly. Okay, never go for other things, just read your textbook thoroughly. It will be very helpful for you. Then you should go for that in text question, then the examples are and exercise. It's enough for you. Okay, and I am here to teach you everything and then you should go for the book and it will be helpful. Okay, and if we increase the concentration much high, so high, if the concentration is so high, then do you know where it used? If the concentration of fluoride ion is so high, then it used in red poison. Okay, so just see that how much important to learn the concentration part. Okay, if your teacher told you is that you have to make 1 ppm fluoride ion solution just because it's helpful in tooth decay, because then your tooth decay will be reduced. Okay, but by mistake if you going to make a high concentration, something like that, just 5 ppm or 6 ppm, or maybe greater than that, then it's become a poison. So that's why we need to learn that concentration part. Okay, now I am going to tell you about the second topic in your book, and it's types of solution. It's types of solution. There are various type of solution. Okay, uh, first of all, before learning this thing, we need to learn that what is solution. Let me give you an example of solution, and it's a mixture of sugar and water. In daily life we use these things. Okay, just take a beaker, add water to them, and then you should add some sugar and then stir it, then you get a solution. Okay, so just think that what do you think that which is much in quantity? Here the water is in more quantity. and sugar is in less quantity. Okay, so the thing which is in more, it's known as solvent, and the thing which is in less amount, it's solute. You should remember these two things. Okay, so how can we get solution? We get solution by adding solute in solvent. If we add solute in solvent, then we get the solution. Okay, now it's time for types of solution. There are various type of solutions like solid solution, gas solution, then liquid solution. If we add gas in liquid, then if we add solid in liquid, if we add liquid in liquid, there are various type of solution is there. In your book, I'm going to give you the chart here, somewhere here. You should see in this video, and you just remember these two things. Just we how can we make solution. Okay, and after that I am going to that concentration part, that concentration of solution. It's a very important topic. You have to learn this, that concentration of solution. Please ignore my handwriting, it's really too bad. I have to work on it. And please go for your book. Yes, everything is there. I have to explain these things to you. Okay, now it's concentration of solution. First of all, there's two type of concentration. One is quantitative and another one is qualitative. Okay, we have to concentrate on that. Okay, we have to learn these things mostly, because qualitative is not used most of the time. Quantitative is used. Okay, just tell me one thing, that if you have two beaker, in the first beaker you have 100 ml water, and second beaker there's also 100 ml water, and here we add 2 gram of sugar or salt, whatever it may be, and here we add 10 gram of sugar. Okay, so what do you think, which concentration is more? Obviously this one, right? So here we can tell that this is more concentrated than that. But how can we determine in some solution which usually used in daily life, like if you in your practical exam, if there is some solution and you have to tell that that the concentration, that we need to learn some new. These are new for you. So first of all, it's mass percentage. How can we determine this? It's mass percentage. There's everything in your book. You just go through it. I just explain you these things. And mass percentage is, how can we determine that? It's the mass of component divided by total mass into 100. I mean that if you have to calculate this mass percentage, then you have to mass of component means that mass of solute, which is in less amount, and here the total mass of solute and solvent both. Okay, and just multiply this in multiply these things into 100, and you will get that mass percentage. And the second one is volume percentage. Here you have to take volume of component, and in the below there is total volume into 100. Then you get that volume percentage. It's really easy. These are easy things. And the third one is ppm. I mean parts per million. Here you have to put that the number of component in the above, number of components, and then in the below there's total number of component. There's total number of component. Here the important thing is that here we have to multiply it by 10 to the power 6. That's the only different here. Okay, everything will be same. The different is that here we have to multiply by 100, and here we have to multiply by 10 to the power 6. Yeah, that's it. And but mostly we don't have seen much question from this topic. We get from I checked this last year papers. Then what I know about from that mostly questions are come from mole fraction and molarity with this topic. So okay, next I am going to teach you about mole fraction. It's really very important. Just try to understand everything. And okay, and the fourth one is mole fraction. From fraction we should think like that. Yeah, if we have a think like this, if here three things like a this much of fraction, we have this much of fraction, C have this much of fraction, something like that. Mostly in class 12 we only learn about mixing of two components, mixing of two components A and B, A and B. So in a whole component there's some fraction of A and some fraction of B. Okay, so first of all, if we want to calculate mole fraction, so you need to know about it. What is that mole? We know that we already learned this about mole in our first year, but let me again tell you this thing again. If you forget, then okay, mole of A, let mole of A equal um, Na, and mole of B equal NB. How can we calculate mole? Mole is like, if you have to put the given mass in the above and then molar mass in the below, and that's it. In this way you get that mole. Okay, so and that mole fraction of A, it's denoted by XA, and XA equal, we have we have to put mole of A in the above and the total mole in the below, and the total mole in the below. Okay, and if we have to calculate mole fraction of B, then you have to put the mole of B in the above and the total mole, I mean the mole of A and B, addition of these two mole and this is total mole in the below. And in this way we can calculate mole fraction. And now I'm going for some example, then it will be more clear for you. And then for this thing, I first I add an example, and then I'm going for an in-text question, then it will be more clear for you. And then you should go for that exercise part and just see that if there is any question of mole fraction, then you just try to solve it. Okay, and now I am going to write that question. After that I will explain it. I am going to solve this question. See, here we have to calculate the mole fraction of ethylene glycol, which is in 20%. Okay, so from 20% we have to know that there's 20 gram of solute which is in the less amount. Okay, remember that. And then 20 gram of solute present in 80 gram of solvent. 80 gram of solvent. Okay, so 20 gram of solute present in 80 gram of solvent, that means total is 100 gram. Okay, so whenever you give 20%, then you should like 20 gram in 80 gram. Okay, if there is 30%, then it's 30 gram in 70 gram. If there is 40%, then 40 gram in 60 gram, something like that. Okay, okay, so here we get that here the solute is ethylene glycol and the solvent is water. Okay, now we have to calculate the mole of ethylene glycol. Mole of ethylene glycol, how can we calculate that? It's by given mass divided by molar mass. Here we know that we can take it as Na. Okay, so here we know that given mass of this solute, I mean this ethylene glycol is 20 gram. And what is that molar mass? Okay, we know, yeah, we learned these things in first year about that how can we calculate molar mass. Here is C2H6O2. So it's how can we calculate that molar mass? It's like here is 2 number of carbon, so 2 into the molar mass of carbon is 12 plus here 6 number of hydrogen, so 6 into molar mass of hydrogen is 1 plus here 2 number of oxygen, so 2 into molar mass of oxygen is 16. So it will be like 24 plus 6 plus 52, so 30 plus 52, it's 62 gram per mole inverse. Okay, so the molar mass is 62 gram per mole inverse. If we calculate this, then we get we get 20 divided by, we get it 0.322 mole. And if we have to calculate the mole of water, so mole of water, maybe it can be visible, so I have to wrap this thing. Okay, so mole of water equal given mass by molar mass. How much given mass is 80 gram, and we know that molar mass of water is H2O, so 2 into 1 plus 16 equal 18 gram per mole inverse. The unit of molar mass is gram per mole inverse. Okay, and then if we calculate it, then we got the value is 4.444 mole. Okay, so we have NB, we have Na. So it's very easy to calculate the mole fraction now. So mole fraction of ethylene glycol, that means C2H6O2 equal Na divided by Na plus Nb. So Na is 0.322 divided by 0.322 plus 4.444. If we calculate these things, then we get the value around 0.068. Okay, so now we have to calculate the mole fraction of, now it's XA. We have to calculate the mole fraction of, mole fraction is denoted by X, okay, of water. So it water is taken as B, so XB equal 0.444, it's NB, its value of NB divided by total 0.322 plus 4.444, then it will be like around 0.932. Okay, but there's a shortcut also here. See, if we mix a ethylene glycol and water, okay, so there is some fraction of ethylene glycol, there is some fraction of water. So this is the fraction of ethylene glycol, this is the fraction of water. So if we add these two, like XA plus XP, then how much we get? 1. Okay, just remember that fraction of XA, fraction of XP, if we add this thing, then we get 1. If there is 3 things should be mixed, like if there is XA, XP, XC, if you mix 3 things, then it will be like XA plus XP plus XC give 1. Okay, where is this XA, XP? These are the mole fraction, like fraction of A, fraction of B, fraction of 6, something like that. But it's no need to learn these things, you have to learn this only. Okay, so if we need XA value, if we know the value of XA, so we can determine XP value very easily, something like XP equal, from here we know that XP equal 1 minus XA, so XP equal 1 minus XA, so 1 minus 0.068, so it will give 0.932. Okay, that's it. In this way we can calculate this. Now I am going to teach explain you that example from in-text question, and then today's video is over, today's class is over, and then from next class we learn about molarity and something like that. Okay, so now I'm going to write the equation, or write the in-text question. Okay, now I am going to solve this question of 2.5, that means it's a question of index. Okay, here the question is calculate the mole fraction. Since we learn about mole fraction, so I skip that molarity and molarity. I teach these things in the next video. I will teach and calculate mole fraction of Ki if the density of we don't need to need that density. It's need only for molarity and molarity. So we have to calculate mole fraction, and their percentage is given 20%. Okay, so 20% Ki solution. That means 20 gram Ki present in 80 gram of water. So from this we came to know about the given masses. Okay, so we know about given masses. Now we have to calculate the molar mass. In this way we came to know about mole, and from mole we can calculate usually that mole fraction. Okay, so these are given mass. Okay, so mole number of mole of Ki equal given mass by, how can we calculate mole? Given mass by molar mass. You must have to remember this formula. So here given mass is 20 gram and molar mass is 20 gram per, extremely sorry for that. Molar mass we have to calculate. So for Ki, potassium have molar mass, it's like 39.10, and for iodine it's around 126.90. so if we add these two, then it will be around 166 gram per mole. It will be around that. Okay, so 14. Okay, so it will be 166 gram per mole. If we calculate this, then okay, I can do that calculation part in some time later. Okay, and if we calculate number of mole of water, I mean H2O, and given mass is 80 gram, and its molar mass we already know that it's 18 gram per mole inverse. And if we calculate this, then it will be 4.444 mole. So we have Na, then we have Nb. Ki is taken as A, water is B, so it's Na and B. So now we have to calculate the mole fraction of Ki only. No need to calculate the water. Here in question we have to calculate the mole fraction of Ki only. Mole fraction of Ki. Ki means A, so it's Xa. If we calculate Xa, then formula is Na divided by total mole, I mean Na plus Nb. So the value of this is around 20 divided by 126. So 20 divided by 166. So it will be 0.12. So we have to put this value in this equation. Na value is 0.12. Na plus Nb, it's Na value is 1.2 and Nb is 4.444. And if we calculate this, then we get value around 0.26 mole. So that's it all about today's class. From next so you have to practice those questions. If you have any confusion, then ask me. In this video, in this comment section, you also ask that, and you have to learn a lot. You have to practice this question. You have to go through the every line of this book, and then you just try to practice some exercise question about only mole fraction, because till now I only teach you about mole fraction, and then the types of solution and why we need to learn this chapter solution. Okay, so that's just all about today. Thank you so much for listening, and Hope you all doing great and take care a lot and study very well.